Hey everyone, hope everyone is doing good. Hey Spurskin. Oh yeah, people are here early. Usually there's like a ramp up before people pop into the stream. Thanks everyone for being here. Ooh. Y'all heard about my huge one? Apparently. Looking forward to the math league. I haven't done an induction proof in a long time. Let's see if I can remember it, because this one looks kind of fun. There's 3 steps. They're pretty formulaic in the structure of the proof, but how you get to the end isn't always easy. So let's see if we can figure it out. Dish-shaped nuggets? Oh my god, in Highway, yesterday when you're doing that speech, like, you were cracking me up at, like, the one that Anders clipped. Like, me being like your dad with that hint. Like, I was like crapping. I was cracking up and could not stop laughing. Let me see if I can find it quick. Sorry, because I'm already getting distracted and the stream has barely started, but it was too funny. Highway math help. It's that over there, kiddo. Shoot, where the heck do you find clips? Oh, dang. Too bad at finding them. 5 hours forward from 10? That's 3. A 6-man yesterday? I don't even feel that bad then. Okay. I mean, I can't find the clip. I would have linked it otherwise, but Highway is really funny. That's the moral of the story. God, dude, a 6-man, like, we definitely could have played it a lot better. Like, I definitely saying that Tizzy building I think was just not good, but I don't know. I should have said something sooner, I guess. Because by the time we did try to leave, it was too late. But okay, let's look at this induction. So the sum from 1 to n of r cubed equals n to the 4th over 4 times n plus 1 squared. Okay, so first with induction proofs, I'm not covering up. Okay, good. You prove the base case. Anytime we'll yell that we need to leave. Okay. Yeah. I definitely we didn't get started off on the right foot with Jake going up in that tower, but honestly, I do respect it because going into those crazy positions is kind of fun. So first we prove the base case with, in this case, we're starting our summation from 1. So we're going to take n equals 1 as our base case. So on the left side, I mean, I'll just rewrite it. R equals 1 to 1 of r cubed is equal to, now we're taking n equals 1. So 1 to the 4th over 4 times 1 plus 1 squared. Now sum from 1 to 1, you just plug in 1 on its own there, and you get 1 cubed, and 1 cubed is just 1. Here you get 1 to the 4th is just 1, over 4 is just 4. 1 plus 1 is 2, last time I checked, and 2 squared is 4. So we get 1 is equal to 1/4 times 4, which is just 1. Base case proves. Now we assume for step 2, we assume, how do we phrase this? I usually just say like assume n, but basically you assume that it's true for n, and then we're going to prove it for n plus 1. And it's very weird when you first see it, but it does make sense eventually. I'm speedrunning it. Prove n plus 1. Okay. So now we plug in n plus 1 here for everything. R equals 1 to n plus 1 r cubed equals n plus 1 to the 4th over 4 n plus 1 squared. Okay. So where we had an n, we now have an n plus 1, and we basically need to... So we've assumed that it's true for an n, which we have our n case here, and we need to show that it's true for n plus 1 down here. So we're going to need to use this fact down here, but we need to arrange it to get it in the right format, and that's kind of the basis of this proof. So we can do... I think what we want to do is we have a summation here. Instead of doing it up to n plus 1, let's just make it up to n, and basically split off that n plus 1 term to the outside. So this and that are completely equal because we're starting from 1 to n plus the n plus 1th term, whereas it's just like compacted in that first step. But we want to actually split it out because the goal is going to be to use this fact in some way, so we do need to be up to n so they match. I don't know exactly where this is going, but this is usually how you do these types of proofs, so just assuming that this is right. Over here, I don't know what we wanted. n plus 1 cubed? Oh, you're right, Jed, thank you. You're right up those sound alerts. Actually, hey, we should do a save. Add save at Jed. Now, hopefully it works. So Jed should have, I think, 2 right now. If this actually worked. Wait, come on. No, stupid thing isn't working. Come on. 2, okay. I think I just typed that second command in too quick. But I think it's kind of working now, this whole like save and add save thing. Or I think it always has worked, but it's just been weird. Like, how many do I have right now? I think I gave myself 1 or 2. Okay, it just doesn't feel like working, I guess. Come on. You need to... I have to ask it twice, I guess. But I think it's really annoying. But yeah, thank you for that, Jed. Now, I guess, I don't know if we want to do... I think we don't want to do... We don't want to make this n plus 2. We want to actually multiply this squared out and pretend the n plus 1 is just one thing. You have to work, Highway? All right. Well, hope work goes well. Thanks for the well wishes. Yeah. See you around. Okay, so let's we're gonna pretend this n plus 1 is just one unit. Like we had x plus 1 squared. Let's multiply this thing out like it's x plus 1 squared, but instead of x we have n plus 1. So first we have n plus 1 times another n plus 1, so we have n plus 1 squared. Then we'll have n plus 1 times 1 plus n plus 1 times 1, so we'll have plus 2 n plus 1. And then we'll have plus 1 times 1, which is 1. Okay. And where is this gonna go? This might not be right so far. Let's just keep it going though and see what happens. Maybe I should come up to the upper left though. And substitute. Yeah, we could do like, you know, call n plus 1 x or something. That's probably what I'm thinking about. I don't feel like I have to do that, at least yet though. Oh, Steel Cyan is that? Thanks for the follow. I hope I said that right. He's the principal of homeschool. R equals 1 to n. R cubed plus n plus 1 cubed And now I think what we want to do on the right side is multiply this n plus 1 to the 4th over 4 into each of these terms. I'm not sure where this is going to go, which is why I'm getting a bit nervous now, but let's try it. We need to somehow make this mirror the format there. Or, like, or I mean, I guess we need to make it actually maybe be exactly that. N plus 1 squared? Oh wait, no, this should be m... No, that's actually what we get, isn't it? Interesting. Maybe we did need to do m plus 2. Improve their equal. What I'm trying to do is, at some point, I want n plus 1 cubed to subtract and cancel out with something on the right side. Like, I want n plus 1 cubed on each side of the equation. And then ideally, we just get this original thing back. But the more I think about it, the more I don't think how I did exactly is right. Because we need an n and then an n plus 1. But all of my things right now are n plus 1. I would need an n plus 1 and an n plus 2 to match that format. But I don't know if I even want that either. Huh. So maybe let's back up. I think I want to do n plus 2. I've investigated this a little bit. I mean, doing it that way might still be right, but I'm not sure. But Noe, how's it going, man? Definitely doing math. But at least, Jed, when I see proofs by induction, they don't normally like just sub in like that. I'm not sure it's for a reason, but you're doing good. About to make some food, but then go to bed. Nice. Let's try with n plus 2 squared and see how this looks. I think I'm still going to multiply out the n plus 2. Let's actually do that in this. N squared plus 4n plus 4. And now I'm thinking we multiply this term into all of those, and hopefully something good happens. We'll find out, though. I'm just going to not write the left-hand side again, because it's a pain. N squared. I don't know where... this might not be right either. Okay, so... What's up, Jed? This is weird. This should be working out better, I feel like, but it's not. Let's see what you're saying, Jed. N plus 1, n plus 4 minus n. Does that help? Oh no, that is that true? I guess it is. It isolates in n plus 1. True. Maybe we do plug in for that summation. You might be right, Chad. I'm a little bit rusty on my proofs by induction, but maybe you're right about that. Or about that, that part. thought this would work out algebraically much more clearly. This would be like there'd be something more obvious for me to do here. And it doesn't seem like it so far. Can you try to factor in n+1? You could. No, I haven't tried for frozen grapes yet. Wrong answer. I keep forgetting when I go to the grocery store. Huh, okay, let me look up just a normal proof by divide all sides by n+1 cubed. The summation term. No, never mind, okay. No, let me just look again at a, just like look up a proof by induction again, just so I can see the format again. Because I have the steps memorized by heart, but the actual mechanics of proving the n+1 case, I'm not really remembering as well as I thought. Stanford, that's where smart people are. See what they have to say. Found a question? Yeah, sure, if you want to post it. Cambridge interview question from 6 years ago. Okay. he's working on his first scan. Links are open for anyone to put in chat, or you can retype it or put it in the Discord. Or square root 3 minus 2 root 2, and that has like an exact value, I guess. Oh, like, oh, for what they're equivalent to. Okay. I've seen questions like that, but I never actually looked at the solution, so I don't know the technique. Let me try and figure out this induction. And then I'll take a better look at that one. I seem to need to show that that's somehow a perfect square. Like 3 minus 2 root 2 is equal to a plus b squared in some way. So Chef might actually be right there. Yeah. Come on. You can load website. I believe in you. It's just this, like, I can see, okay, there we go. Oh yeah, you do it for k+1, not n+1. Technically, if you're being rigorous. Okay, this one's probably closer to what I'm trying to do here.
Shine bright, they were puzzled how I'm saved. I could never serve the passion or the fire or the man or for sight how I am. Ain't nobody asking, I've been basking in my liberty, cause slavery is real. Doesn't mean the shackles gotta be revealed. Fighting with my pen, it's the closest.
Just square root for scan, that's how it's usually abbreviated in English. So it's like a big square root, 3 minus 2, a smaller square root 2.
Label still persuading like I'm needing a dime. Like my people ain't be dying over gold in the mines. It's funny, right? I'm still numb to the trauma. I couldn't tell if my joy was out of love or what would hold me when I needed me a hug. That's the realest. Yeah. It's the closest thing to feeling. Yeah, it's the only thing
Plus k plus 1.
trying to get me closer.
Oh, maybe I set it up wrong.
Why these words get to show you all my flaws. It's poetry and pain.
Because they only work with the right hand side here, so they do.
Yeah, it's poetry.
If this
You wanna go
summation.
for a walk?
Oh, Zach. Thank you, Zach. How's the math? Well, I really want to look at the problem that I had to deal with involving like the maxima of functions. That heptagon one was also pretty interesting though. And right now I'm looking at an induction problem that I'm a little bit rusty on, so I think I did. We need to take our right hand side and just add whatever the next term is, and then try and get it in the same format as originally. Okay. So this is the actual problem, and I think I just set up the last induction step wrong. And then after that, then we put a question in. Just to do for fun. So let me erase this. I think what we want to do here. Sorry for the booty stream. Oh, and Turbulent Welder, thanks for the follow. Sorry if I didn't say that. Okay, so I think what we want to do is we want to take. Ooh, let me actually erase that a little bit more. So we want to show. We want to get to this, and I think what we do is we take this initial assumption, we add n plus 1 cubed, or I guess k. I should be using k, because it's bad form to use n. Let's use k. It's been a minute since I've done induction. They're pretty fun though. So, we want to take our initial assumption, plug in k, just k, not k plus 1, and then we'll add our k plus 1 term to each side and try and get it into this format. So let's come over here. So, take the initial assumption with k, but we're going to add k plus 1 cubed to each side. I think I was doing a little bit backwards, where I started with k plus 1, or directing the formula rather than adding it in. And now working only on the right-hand side, we want to get to this end result. I think that's the better way to structure this. So I think we want to, immediately, I want to, oh no. Do I? I could pull out a k plus 1 squared. I don't know if that's going to be good or bad, but let's see how that looks if I do factor out a k plus 1 squared from each term. So that becomes k cubed over 4 plus k plus 1. Okay. Now this, I don't really know what to do with. This shouldn't be this hard, right? See you soon, Shep. There must be something obvious that I'm missing here. So if this isn't the right first step, then what is? What is induction exactly? It's a type of proof. It's especially used with basically like number theory-ish relationships like this. And basically the way the proof works is you show it works for your base case, whatever your first one is. For the way this is structured, we take n equals 1. And you assume then that it works for any value k, and then you prove that it works for the next value after k. And because you already proved it for the first one, that has kind of then proved it for, we proved it for 1, and this set will prove it for 2, which proves it for 3, which proves it for 4, and it kind of like cascades. Hey Zone, I have a third power, it should be 4? Oh, that should be 4, you are absolutely right there. Thank you. My first step, well, factoring out k plus 1 squared is still wrong with that. Wait, why did I rate it to the 4th? Oh my gosh, Zone, thank you so much. I copied on the problem wrong. That's not the first time that I've done that. Wow, why did I make that a 4th? Probably because the 4 in the denominator. All right, that's a save. Yeah, that'd be. Let's try solving the actual problem that we were asked to solve, rather than just a random one that I made up. That's a nice save. Change reminiscent of last night's problem. Is it gonna be telescoping in some weird way, or have you already like worked this out, Zach? Reading the question. Oh, you're right. Yeah, with not reading the question. Yeah. Okay. Dude, I'm really bad about just... Normally, when there's a really hard problem, I just accidentally write down an easier one and solve that and pretend like I'm super smart. But reading the whole question. Yeah. You're right. Okay. N squared over 4, n plus 1 squared. All of this math down to here is still valid. This, with k plus 1, is still valid, or it's now valid that I fixed it. So now let's come over here. Okay, how does... So now, okay, let's try again the k plus 1 squared thing, because we're gonna have a quadratic inside, and maybe that'll be factorable. Just see how that looks. So now we have a k squared over 4 plus k plus 1. Is that factorable? If we multiplied it through by 4, k squared plus 4k plus 4, yeah, that's factorable. Just, I don't know if that's good. Let's just see how it factors though. Okay, so, oh, I see it. Okay. We have to factor out a 1/4 from this. So let's do this in 2 steps. Just to show it out nicely. Times 1/4. And when you factor out a fraction, you multiply the reciprocal. So it's k squared plus 4k plus 4. And this is going to work out actually kind of beautifully. I can put k plus 1 squared over 4 here. And this factors out to k plus 2 squared. And don't you know it? Bam, bam, they match. Okay. See, that is simple. I just need to write down the right question. Okay. Found a new tool? Oh, what's that? Let's see if someone posted the answer already. Regardless, that was a fun problem to do. And then we'll look at Ben's question. MathCha? Matcha. You're learning how to write math? Let me type this out, and if you want to like drop a link, it'd be interesting to see. Like something that explains what it does. I see you DM me. Since you said you're comfortable with these steps for induction, I'll skip straight to proving the k+1 case. We'll take the base k, or we'll take the, no, I shouldn't say base, we'll take the k case and add k+1 cubed to each side. So sum from r equals 1 to k+1 of r cubed is equal to k squared over 4 times k+1 squared plus k+1 cubed. Okay, oops, needs parentheses. From there, I would recommend you factor out a k+1 squared from the right side and see if you can do any further factoring. I think MATLAB is paid. I got it for free through my school, but I think you have to pay for MATLAB. Free online editor for math stuff. Oh, okay. Okay, so I think that's a good enough. They didn't post their attempt, so I'm not going to post the entire solution for them. But that hopefully gets them started, and it prompts them to potentially ask a question back to me, and that is a way that we can get them to work on the problem for themselves. So let's see, this is... Oh, this is, So MATLAB is actually a programming language that's really good at making computations. LaTeX, like spelled like latex, is what you use to do like math typing like this. Which that, I mean, there's probably paid editors. I'm sure there's also free LaTeX editors. So let's quickly look at this. Is that Maple? Oh, okay. It's probably worth a bookmark though, if it is just like a nice LaTeX editor. So, okay, so first you get the k+1 in there. Yeah, so that used my initial setup, which maybe is a little bit dubious, but I think it... No, this is just a different structure entirely. So you're able to make the first thing that I tried work, I guess, it looks like. I haven't spotted an error, at least not yet. So you subtract the k+1 cubed over to the other side. Oh, so that does work out. I wonder if there is some kind of logic error in that. That's what I was trying to do initially. Oh, and it didn't work for me because I had to the fourth. So I don't know if there's some kind of implied logical error in like using both sides of the equations, but this is what I was trying to do initially, and I don't know if that was actually right. I'll do this later. It's probably a bit too hard for me to figure out right now, but I'll look at Ben's question because it's been a bit. So let me erase this and I'll scroll up and pull up Ben's thing. Actually, do you go, or is your name actually Ben, or is it should I call you Benoe, or I've just been assuming that you're okay with being called Ben, but I should have asked you. Oh, excuse me. Okay, I wasn't completely sure because there's also Ben Stormzy. So I wasn't sure if you guys are both Ben or if that was kind of like team or something. My real name Don Doe. Yeah. Oh, you're both Ben. Okay. Get a clean page to play with, but it's nice to have something I'll trust for you. Oh, okay. That makes sense. Okay, so let's copy down Ben's question. Root 3 minus 2 root 2. And option A is root 3 minus 1. B is root 2 minus 1. C is root 3 minus root 2. Okay. Okay, so looking at this, I haven't actually seen a solution. I've seen many problems that are like this. I've never actually seen a solution for one though, so I don't know the general techniques. My assumption is that we need to show that since there's a square root underneath, there's like the big square root here, and none of these have a big square root, we need to somehow show that this is 3 minus 2 root 2 is equal to some a plus b squared, or maybe a minus b squared. Some kind of perfect square, so that way the square root on the outside goes away. So I assume we'd have to take a minus b because we do have the minus sign there. So if I just took maybe a simple case with like, we're gonna have, we have a minus b times a minus b. This is a Cambridge interview question 6 years ago. Interesting. Question, it's Luxembourg Olympiad question, really? Okay. I assume then if the a's need to multiply it to be 3, then a needs to be root 3. But potentially there's going to be some guessing and checking, I think, and seeing what goes wrong. We have root 3 and root 3. When these get multiplied, we'll get that 3 over there. Now we also need maybe a plus root 2 and a minus root 2, but I think we're gonna get an extra term. Let's just see how exactly that works out. So 3 times 3 is 3. Plus root 2 times minus root 2 is minus 2. And we actually don't get the middle term, so this isn't good. Actually, and I just made that a plus and a minus. They should both be minus because they need to be squared. Oops. I was thinking that we need a cancellation somewhere. Yeah, you're right, Ben. Root 3 times minus root 2 is minus root 6, then minus root 6 again, and then plus 4, so, or plus 2. So I don't think this is going to match any of our answers. We get 5 minus 2 root 6, which is no good, I don't think. That's how I'm interpreting this. So I don't think it's possible to make a plus b work because we do have the minus sign there. So we need a minus sign coming in somewhere. Now, do we need to make it something a little bit crazier that happens to also get the right answer? Like this is 2 root 2, which is actually the square root of 8. So what if we tried to get these other terms to come out to be root 8? 2 root 2 minus 2 root 2. Like what does this look like? Because these will multiply to be 8. So we get 3 again, minus 2 root 6 minus 2 root 6 plus it just said that'd be 8, right? Yeah. And then this comes out to be 11 minus, oh, I thought that would work out a bit differently. but it doesn't. In theory, we could work backwards and square each of these. That might be a more efficient way. Like, it's cheating because we're working backwards, but if you're under a time crunch with an interview, I think you would just square each of those and see which one matches, right? And already tried root 3 minus root 2. What happens if you did do it that backwards way? Like, am I even thinking about this right? Like, root 3 minus 1 squared is 3 minus 2 root 3. Plus 1? Which doesn't match that. Root 2 minus 1 squared. 2 minus 2 root 2 plus 1. Ah! That's 3 minus 2 root 2. Okay. So the answer is B. But this is kind of cheating. Because I'm working backwards rather than solving it directly. I wonder what, like, if this was an open-ended question rather than a multiple choice question, that there must be a technique to do this that's better than what I was trying. Oh wait, you know what? I think my error was I was using the root. The 3 is just a whole number. Like, I shouldn't be worried about that. I should only have. Okay, yeah, that's why. I think my error was thinking that the 3 needed to be square rooted. I should have actually set up my parentheses something like this form and trying different things, because the 3, it doesn't need any radical. It would still be guessing and checking using my thing, but this would, I mean, obviously it's a lot closer to the original one. You safely assume A equals root 3. If so, sub x equals B. You assume A equals square root 3. No. I think I found out why we can't safely assume A equals square root 3, because that's what I was trying. But the actual answer doesn't involve a square root 3. So we have 2p plus 3 greater than 2 parentheses p minus 3. And so I'll call this like A, B, and C. P greater than -9. Or all real numbers. Oh wait, I'm confused on how these are divided up. There's 2 all real numbers. Okay. Oh, okay. All real numbers. E greater than -3. And D is no solution. Okay. Yeah. I know you're going to have to make it basic, Jurha, but thank you. I'll get the dark side. Okay. So there are some special rules for solving inequalities. I don't think we're going to run into them with this problem, though. For this, we can kind of pretend it's like an equal sign. I think. So let's rewrite the inequality down here so I can work with it. Now let's multiply it. I don't like the parentheses being here. So let's multiply the 2 inside of each. So when you multiply the 2 to the p, you get 2p. Multiply 2 by -3, you get -6. And now we want to get the p's on one side and the constants on the other side. So let's subtract 2 from each side. You can see the p's are going to go away because they're both 2p, and that's okay. So let's actually no, we don't need to worry about the constant. So the p's are going to go away because they're both 2p. And we end up with 3 is greater than -6, because that 6 still has the minus sign. That is a true statement. 3 is greater than -6. So I think the answer means that it's all real numbers, because that's just a true statement. If it involved p's or something, we might have gotten A or C. And if we think about it differently, yeah, Jed, I was about to say that. If we look at just the second line here, 2p plus 3 is greater than 2p minus 6. You have the same number, 2p, but for when you add 3, the other one you subtract 6. So in that kind of more intuitive sense, I guess I hate saying it that wishy-washy, but if you take the same number and add 3, it'll always be more than the same number subtracted by 6. Yeah, exactly, Peach tea. Okay, so like you understand dork side. And Maxi, the continuous case for the ant problem. Oh, wow. Oh, okay. Our numbers makes the most sense. Right, because you can plug in any real value p you want and get a valid answer there. Oh, Chef with the coffee emote. Love it. Another approach, Jen? Sub in some numbers. Oh yeah, you could Jed is Jed is saying another way that you could solve this based off the answers that are given. You can test each one where if p is greater than -9, you could try a p that's less than -9 and see if it still works. So if you tried p equals -10, you should still get a true statement. And actually, I mean, that right there would be enough to tell you that it's all real numbers, but... right, Peach Tea. They'd be 9 units apart on a number line. Yeah, so... it's maybe not the best habit to have. I mean, we might be beating a dead horse here because Dorkside seems to understand the best technique to solve it, but it is also possible, if it's a multiple choice question, to try plugging in values of p that fit with each of the answers. But of course, if it's not a multiple choice question, then you wouldn't know. So I'm not going to try and explain it to death, but Dorkside, if you have another problem, please let us know, I guess. Or if that was it, then even better. Well, I must have to answer your questions, but even better that you all squared away. That's what I might be able to do. You're right, I don't have a high emote. That might be a problem. I don't have a good idea for a high emote. I could just do me waving or something, but I don't know. I overthink my emotes too much, I think. And then I feel like they don't actually convey emotions. But I don't know. Need more cat emotes? We'll just type. I know, what are we, plebs?
You cook the shit out of it!
The graph of fx is shown. It goes to the plane 1,4. That's your favorite? I love the way he says that. I took it from his podcast because he tells a really funny story about how his dad like he would want all his like all his meat to be like barely cooked, like nearly raw. If it was ever slightly more cooked than that, he'll go, "Bryce, you cooked the shit out of it." Bill Burr's impression of his dad is just, it kills me every time. Something in their face. Did learn a lot, but not for your studies physically. Yeah, it's something just have like any kind of work experience that's not directly relevant. Did Bill Burr say that? Or is that just from something else? Charles, I haven't heard that person. I have a... Yes? I really want to. I said there's this other thing that's happening at the exact same time at 10 in the morning, like my time, and so it's only gonna last an hour, and so I might join it an hour late. But like two things that I both really want to do, and I have like a deep conflict about if I should just do one and make it better for that, or if I should like split my time. But I might be late, but I'm definitely going to try and stream snipe Senny. Central, fuck you. That must mean you're doing okay. Hope everything went well with you. Oh no, like it's something that I really like. I want to do. I just need to like figure out how it's gonna work. Cause I'd have it's like a copy related thing for an hour, and then it'd be DayZ for like 2 or 3 hours, and then it's still a math day for me. So I'd want to do math after that. So I think I can handle all that in one day, but yeah. Hopped up on painkillers? That sounds nice. Sneaky bastard hiding in the dark. So yeah, I don't know how much people are like teaming or anything like that, but I'd definitely be down to team up with people. Listen to what you thought was hours. Was 30 minutes? Okay. I can get a good zoom level on this. Let me see. It looks like logarithmic. Well, wait. You must be on your phone right now because they didn't let you bring your laptop, right? So this is a logarithmic graph, but it's not y equals log 2x directly. Horizontal translation by -1. -1? Wait, I need to... Feeling bad a little bit ago, but not too bad now, just some pain. Okay. Improvement. I guess it is a -1 translation. No, it's not. This makes no sense. If it hits the x-axis at -1 here, and it hits the x-axis at +1 here, isn't that a translation of 2? -2? I have an improvement? Thank you. Yeah, I figure if he's giving me shit, then he's probably like he's probably doing decently. It makes sense, but like the website said that -1 is right. You shit, so it's a bad indicator. You know, you're probably right. It is right, Maxi? It looks like it hits the x-axis. I mean, I guess it goes past well... No, but if the point 1, 0 turns into -1, 0. How is that only a translation of -1? Oh, the asymptote is on there? Oh, it's upshifted! Duh. Okay, that makes sense. Of course the 0 will change because you also shift it up. Never mind. So look at the emergency room if you felt ill. You went to sleep instead, so fuck up. Oh, you're like right back at home? Be careful about doing that, go fuck yourself. There you go. The vertical shift is 3. Yeah, I guess I want to track this 4 points. Do we... Is there an easy way to solve for this? So you could do like y equals a log base 2 of x plus b plus c. Like the most general form of this log equation, try and solve for a, b, and c, but I don't think you have enough information. You're right, it should... Whoa. Yeah, because... Oh my. Man, this feels weird when you have both the shifts. I feel like there should be a better way to do this, but... Is it that... If this is the normal y equals log base 2 of x, we do have the point 1 comma 0 there, but then as in the process of us shifting around, we're shifting it both up into the left. So actually we should be tracking like the point 2 comma 1, because that now becomes the 1 over here, shifted up by 1. I'm reverse engineering it though, knowing the answer. All right, Bombback, sleep well. Thanks for coming by. Wait, I'm like arriving to the answer that you already put, Maxi. I like I have benefit of your hindsight, I guess. Because yeah. I feel like there should be a better way to do this. Like, how do you know it's a shift of 1 horizontally? This is really tripping me out. This asymptote. Oh, normally it's at 0. I keep on thinking it's at 1. I guess you're right. Okay, so that's what I was confused on, because I didn't know how you solve the horizontal shift just on its own. But that makes sense, basing it off the asymptote. And then once you have that like pinned down, you can now play around with the translations. Graph can be obtained from the curve. So for part 2, what's that? The graph can be obtained from the curve y equals log base 2 of x by horizontal stretch, followed by horizontal translation. So it's not unique, apparently. Because this is saying that there's, instead of a vertical translation, you can do a stretch, it seems. So let's investigate that scenario. Yeah, the horizontal is still -1. That they do say horizontal stretch followed by a horizontal translation. I'll bring it up again so you can read it, Maxi. They do say the order specifically. Horizontal stretch, then horizontal translation. And actually, I don't think it actually makes a difference. We set the equation. Oh, not that marker. We set up y equals a log base 2 of x plus 1 is the horizontal translation that we want. And we know the points 1, 4, so we plug that in to solve for a. Log base 2 of 2. So wouldn't a equal 4? I don't know how they got 3/4. Maybe they didn't do x plus 1, they just did x or something? Oh wait, are you supposed to do it like that? So if you're doing the horizontal stretch... Oh, yeah, I wouldn't be a where I put it. It wouldn't be a in front of the x, because that's the horizontal stretch. What I did is a vertical stretch, right? It is ax plus 1, because when you plug in... Well... That's confusing me now. It might be 1 over a, yeah. But is that really... Is that a horizontal stretch first? If it's 1 over a, that feels like it's... Ooh. Because if you did the translation first, it'd be a x plus 1. So, do we need those parentheses? Okay. Yeah, this I feel kind of good about. That's very weird. But let's see if we can still do our 1, 4 plugin and get an answer. I guess we can verify it after this too. A plus 1. Now we do 2 to the power of each side. 16 equals a plus 1. A equals 15. Really? So if y equals log base 2 of 15x plus 1 over 15, does that give us everything we want in life? B equal 1 over a? Yeah, it seems... This feels strange. Dang it, markers! Will you stop going around everywhere? I try to keep them vertical because they keep on like dying on me. Drying out. Let's plug some things into Desmos because I don't feel good about this. Come on. Then do it. So let's do the result we got from part 1. That's our verification. So it's log base 2 x plus 1 plus 3. And that gives us the point 1, 4. That's good. Now down here we'll do y equals... Should not be 1 over a? Yeah, Let's just see like how this looks. I believe it's yeah. So the blue line looks completely different. It does have to be +1. Like that just can't be anything else. But I see asymptote is wrong. Wait. Is my original answer right? No, my original answer is not right. So if I did another parentheses there. Oh, it is just 1. It looks like a equals 8 just from graphing it. Let's solve it the real way though. That is so strange to me. Maybe I'm rusty on my transformations. How we're supposed to set up, apparently how we set up a horizontal shift, then a horizontal stretch, then a horizontal shift is a x plus 1. Okay. A 1 plus 1 is 2. Okay. How do we, I guess we do 2 to the power of each side still. 16 equals 2a. Wait, oh yeah, a equals 8. I don't have a good explanation for why we set it up like that though. I guess because the a is on the outside, that makes it go first. It is weird to imply order with these changes, I guess. Dang it, and someone beat me to it. Let's see what they said though. Because maybe they have the answer to our question. Okay, this person did exactly what you did, Maxi. Seems for the first one. Second one. What the heck? They do get the right answer at the very end. You still have a huge room for people to eat? I always have that. Asking for me, yeah. I could not have it if I wanted to. I don't understand how this person... Do you see him wink at me, guys? What a flirt, yeah. I don't understand this. They get the right answer, though. Wife's so interested in you. Yeah, I don't know. It's just one of those weird things. Invaded, uninvaded, then ordered rank. What the heck? Is this gonna be some crazy... A student wanted to see if invasion by the plant slender false brome changed soil pH? That's unless we used a random word generator. Is it a plant called slender false brome? Okay. Okay, so I think the actual question is relatively straightforward, though. Oh, wow. Fair enough. Thanks for verifying that. So I think your null would just be assume that they did not change the soil pH. Let's see what that. Let's read again what the actual like misunderstanding is, though. I don't understand that. Oh, I guess to take the average? Flat sloping leaves covered in hairs. Stems grow far past the leaves. Huh. This last part of the explanation, I don't quite understand. I think I can still post about the null hypothesis, though. You're just asking if it changes soil pH. So the alternative will be not equals to. Well, actually, it would be not equals to. I'm trying to figure out how to phrase this, though. That's all good. Is usually a situation that is the status quo. Everyone thinks is true. Whereas the alternative hypothesis is what you're trying to prove with your test. It can sometimes be a bit murky, but it seems like you're trying to prove that the soil pH does change. We do italics again. 1 asterisk. So your I'll say IE not equal to or you're pretty good with plants? It seems like it, yeah. Ooh, actually, I can maybe explain this in a different way. The null hypothesis always involves an equal sign. Is things staying the same? The same being whatever people generally think is true, such as that plants not changing the pH. The alternative is what you're trying to prove and will involve a not equal sign, greater than or a greater or a greater than, less than, slash or equal to. in this case, I'd say the null is the pH in each sample being the same, and the alternative is the pH being different, not equal to. Okay, I hope that helps the little person.